All right. Good morning, people. Um, Here's a recording of the lesson on the 7.3 solving exponential equations in pre-calculus 12. So in the previous class, I mentioned that there are multiple methods of solving exponential equations. And one way is to just solve graphically, just by putting into the graphic calculator, put the left-hand side, y equals left-hand side, and the y equals right-hand side, and you find the x-coordinate of the point of intersection. But then there's more authentic, more algebraic method to solve exponential equations as well, which is the method called equating coefficients. So we saw some examples of it where it's pretty obvious when the bases are the same. Then we also briefly saw the case where we have different bases. And what do? Well, so our conclusion was that when the bases are the same, then we simply match the coefficient, match the exponents. So then when the exponents are the same, we solve the equation by setting the exponents to be the same. Bases are different, well, we attempt to equalize the base, match the base as well. So let's focus a bit more about how we can equalize the base. So let's try some example questions here. So let's first try practice how we can change the bases. So for example, we have a number 27. The purpose is, can I somehow make this number into a power of 3? So we want to change the base to be 3. For example, say for 27, well, can I represent it as a base of 3? We want to find a number and the exponent that should go in is a base 3. In this case, it's pretty straightforward. It's going to be e to the power of 3. That's 27. Well, what about a number like 9 squared? Well, 9 similar for 9 for 27. Well, we know that 9 can be represented as 3 squared. We just have to be careful when we deal with these numbers because we want to make sure that we put the brackets around the number that we want to swap. For example, 9 is switched with 9 squared. I need to put a bracket around 3 squared. And then, using the exponent laws that we learned in grade 9, we know that this is a power of a power case, which means that we multiply the exponents. It's going to be e to the power. If I quickly summarize some exponent laws, the bases are the same and you multiply two exponents with the same base, we add exponents. And if it's division, subtract exponents. Then when we have a power of a power case, multiply exponents. Lastly, let's do the part C, 27 to the power of 1 over 3 times cube root of 81 to the power of 2. It looks really complicated, but let's break it down into pieces. First of all, swap 27 for something else. So 27 can rewrite 27 into 3 cubed. What we just did in part A. Multiply that, well, we power that into. Then what about 81? Well, I think 81 can be rewritten to 3 to the power of 4. 9 squared is 1, so we just did that in part B. And furthermore, one thing that we know about square root or cube root or any radical is that we can rewrite that as the power of a rational number. The rule that we learned about is you have nth root a rewrite it as 8 to the power 1. I think I can rewrite, well, first of all, 3 to the power 3 to the power 1 over 3. We multiply the exponents, so it becomes 3 to the power 1. And cube root, well, cube root is 1 over 3, it's power 1 over 3. Right? Becomes 3 to the power 4 to the power 1 over 3 to the power of 2. Now it means 3 to the power 1 times 3 to the power of 4 over 3 to the power of 2. Because we did 4 times 1 over 3. Then we multiply by 2 one more time. It's going to be 3 to the power of 8 over 3. Finally, when we multiply these two numbers together, we add the exponents. My final answer becomes 3 to the power of 11 over 3. And of course, an easy way to check the answer is by plugging into the calculator. Plug 27 to the power of 1 over 3 times cube root of 81 squared, and then also plug in 3 to the power of 11 over 3, and then see if the numbers match. Now, using these skills that we learned in example 1, maybe you can pause the video and you can try the your turn questions textbook. Then afterwards, let's go ahead and try example. Solve an equation by changing the base. So using the skills that we just practiced in example 1, my initial goal of solving these equations would be to match bases. So in these two examples, we have 4 to the power of x plus 2 equals 64 to the power of x. Well, I would like to use a method of equating coefficients, but the bases are different, so we can't do that right now. So what can I do? Well, there's one systematic approach that I like to do for all cases. I know it's there's an easier method for this exactly, but I'll try another way. So what I like to do is I try to find the common base. The simplest bases that we can think of are numbers like 2, 3. Such easiest ones are these prime numbers. In this case, I know that both 4 and 64, they both have a root of 2 somewhere, right? Because I can write 4 as 2 squared, and I can also write 64 as 2 to the power of 6. So let's switch both of the numbers, both sides, with the base of 2. It's going to be, well, first let's rewrite the equation. It's going to be rewritten as 2 to the power of 2, switching the place of 4, power of x plus 2, and then 2 to the power of 6, switching the place of 64, then to the power of x. And now when I expand it, 2 times x plus 2 is going to be 2x plus 4, then 6 times x is 6x. Then my question is basically complete. Just match the exponents. That becomes 2x plus 4 equals 6x. 4 equals 4x. 4x. Of course, we can quickly check the answer by plugging the values. 4 to the power of 1 plus 2. 1 plus 2 is 3. 4 to the power of 3 is indeed 64. So on the right hand side, 64 to the power of 1 is 64. Let's try B as well. 4 to the power of 2x equals 8 to the power of 2x minus 3. Just like the previous example, both 4 and 8 have the bases connected to 2, of course. 4 can be represented as 2 squared, and 8 can be represented as 2 cubed. Let's rewrite 4 as 2 to the power of 2, power of 2x, and 8 as 2 to the power of 3, power of 2x minus 3. 2 to the power of 2 to the power of 2x, we multiply the 2 times 2x, power 4x. 2 to the power of 3 times 2x minus 3 will be 2 to the power of 6x minus 9. Final answer. Afterwards, I match the exponents. I go 4x equals 6x minus 9. 9 is equal to 2x. X is equal to 9 over 2. And of course, just like before, we can plug in the value x equals 9 over 2, and then we can check the answer. Well, for that, we can use a calculator. So just one note that I want to talk about in this part is that, well, we attempt to find the common base. So for example, in this questions, 4 and 64 had the common base of 2, and 4 and 8 also had a common base of 2. That may not be always possible. For example, we could have a number like 4 to the power of, 4 to the power of something equals 9 to the power of something. Well, 4 has a base of 2 and 9 has a base of 3, and the bases are not matching. In this case, solving the equation algebraically is impossible because we can't equalize the bases. That's why I said last class, when the bases are different, we attempt to equalize the base. It's not always possible that we space. Attempt. In such cases, solving algebraically is impossible right now. We need a special skill that we'll learn in next class or next chapter called logarithms. But until then, we need to find another approach. At this point, pause the video, and you can try the your turn questions on section on the textbook. Let's try the example 3. Christina plans to buy a car. She has saved $5,000. The car she wants cost $5,900. How long will Christina have to invest her money in a term deposit that pays 6.12% per year on a quarterly, before she has enough to buy the car? So, let's put this into a formula. It's a compounding interest formula, and realized yet, but compounding interest is a very typical example of using exponential functions. So you can try to get the compound interest formula. I think the compound interest formula must go something like FV. The final value is equal to principal value, PV, multiplied by 1 plus R over K. R representing the rate percent, and K representing the number of compounding period per year. The power of Kn, where n represents the number. So let's plug in the values that we know of. Well, the principal value that she has is $5,000. The final value she wants is $5,900. And the rate that she's getting is 6.12%. And K, the compounding number of compounding periods per year, is 4. Para for K is 4, and variable that we want to solve. Now, once again, because this is an exponential equation, we have the variable n and as the exponent side. So this means that we can't use the traditional methods that we have known before to solve the equation. So what should we do? Well, we can try to solve it by doing some initial steps, but that's kind of redundant and it takes too long. So I'm going to use a graphing calculator once again. We try to explain how to use a graphing calculator in this case. Well, first we put y equals the left-hand side. Put y equals 5,900. And then I'm going to put the right-hand side, y equals 5,000 times 1 plus 6.12 divided by 400 times 4 is 400. Power of 4n. Maybe we can switch this into x, just so we can easily put it on the Desmos. And then we're going to find the point of intersection. And of course, we're going to find the x coordinate of it. Let's use a Desmos. I'm going to put y equals 5,900, the first line. Then let's put y equals 5,000 times 1 plus 6.12 divided by 400, power of 4x. Right now I don't see anything. Y-axis. Let's put the y-axis going from 0 all the way up until maybe $7,000. Now I see then two graphs and the point of intersection. And the intersection happens at approximately 2.73. Know that the x is approximately 2.73. My final answer would be Sina has to wait approximately 0.73 by the car. So here in this example 3, we saw how we can solve the exponential equations graphically, especially when the bases are weird like this. Of course, there's a mathematical way to solve it, algebraic way to solve it, but that involves using logarithms. So that in next. At this point, you can pause the video and you can attempt to try the last your turn question. And also, you can try to solve some problems in the Check Your Understanding that are assigned on Google Classroom. Right. Thanks for watching this video, and hope you have a good week.